Hello, this is Amos Tarfa. I'm a medical physicist and a STEM curriculum writer and math and science instructor. What I want to do in this video is I want to talk briefly about how to bring math and science to life for your student. I'm going to refer to a few books in this video and I'll give some context in a second. Let me show you the books and then we'll come back and talk. So we have this book right here, Science and the Scientific Revolution. We have Newton's Principia, The Return of the God Hypothesis, Einstein's Biggest Mistake, and then a book on space. Okay. Let's talk about this for a second. Before we go further, you probably saw some SAT books. I'm going to be teaching students ACT, SAT prep Saturdays from 10 to 12 US Central Standard Time or 4 p.m. Nigerian time. So if you want to learn math and science for the ACT and get a perfect score, reach out to amosthemathguy@gmail.com. You can sign up using learningforexcellence.com. That's the website. Okay, let's dive into this. So it seems like one of the reasons we do a lot of maths and science is actually astronomy gave us the basis for that. One of the reasons we do a lot of math and science methods that we use today came from work in astronomy. What do I mean by this? You think about people like Galileo, they put together this telescope, they did great work, and Galileo, Kepler, Copernicus, they set the stage. The scientific revolution happens. I have a separate video and a course I'm doing on the scientific revolution. Reach out to amosthemathguy@gmail.com if you want the link, amosthemathguy@gmail.com, where basically I'm going through Cambridge University, Newton's birthplace, Newton's college, talking about the scientific revolution. Why did it happen? Things like that. But so the scientific revolution gave us a basis for, during that time, we got a lot of astronomy to help us understand the universe and meteorites and just different things in space. Okay. Now Newton comes and Newton gives us the calculus, right? Or gives us one of the aspects of the calculus. We know that Gottfried Leibniz from Germany also did work in that. These guys gave us the foundation for a lot of what we talk about in calculus, but there are other people in the equation we're not going to talk about today. Here's what's interesting though. Think about Einstein. Why is Einstein such a big deal in science and math? Partly because of his work with Einstein's theory of general relativity. Well, what does that have to do with anything? Well, it has to do with understanding gravitation, the whole idea of gravity still, in this idea of why do planets behave the way they behave, and we have a massive object bending space-time. And so it seems like, notice we're talking about the sun and the planets again, right? So physics has this big connection to astronomy. Astronomy, physics, math, and chemistry should really be kept together. Like if there could be one class that combines all of them, that's what Isaac Newton would be. And I went to his home yesterday. I have a video and a series of videos coming out soon about Newton's home, where he was born, and then the garden where this discussion happens about gravity. People joke about that, Newton's tree and the apple, all of that, right? I was able to visit these sites, and it was such a blessing to see Newton's home. Someday I plan to do tours of like giving people a chance to visit Newton's home and then Newton's college, and then we do the math that a lot of math that he came up with. So let's go back to space for a second. So the scientific revolution happens. We have Galileo, Kepler, Copernicus setting the groundwork, and then we have Newton in 1642. And notice that we have Newton in 1642, we have Einstein in 1905. We're still talking about the universe. We're still talking about astronomy. And we need math to explain it. We need mathematics, as we'll say in America. We need mathematics to explain the universe. So what it would mean is if you want to raise the next generation of scientists, mathematicians, and thinkers, top thinkers, here's what you need to do. It's almost like that quote. I'll tell you a quote, and then I'll tell you what you need to do. Think about, someone said, if you want to get people to, build a boat, essentially, teach them to long for the seas. That's a paraphrase, right? If somebody longs for the seas and then you tell them to build a boat or to build a ship, now they want to build a ship because they were longing for the seas. They want to go out to the ocean. They want to go out there. Not me, them, okay? They want to go out to the vastness of the seas. So pause. Why are we telling kids to factor polynomials? Why are we telling kids to work on radicals? Why are we telling kids rules of exponents? Why are we telling kids all these things without first of all getting them to long for space? Right? That's why I showed you the book by Tim Peake, the UK astronaut, about space. We need people to understand the beauty of space and the fact that they can use mathematics to actually better observe and enjoy their understanding of space. Newton gave us the calculus partly because he wanted us to understand He wanted to understand gravity and some of those pieces. Again, Gottfried Leibniz, we can't forget him. For those who are huge Leibniz fans, please know that I'm not removing credit from Leibniz. He was a great guy. But we need to talk about space. We need to talk about mathematics as it relates to space. And then when we talk about Einstein's theory of general relativity, do you know that in order to understand some of that, you need to understand mathematics? Do you see how it's all connected again? Let's teach mathematics from a perspective where students have a basis for appreciating it. There's a point to the story. But what about the topics that don't have any application? Let's address that quickly. For topics that don't have any application, there's a solution. Use mathematics as a way to teach character. Because the crazy thing that you might not know is today, whenever you go to the hospital, or if your relatives go to the hospital and they get an MRI scan or CT scan, well, they get a CT scan or nuclear medicine scan, there's actually something called the Fourier transform that is used to reconstruct these images that the doctors can then read and give you a diagnosis. The man who came up with that technology made it before we ever had any computers. He did it, as a matter of fact, way before we had pretty much anything in the big technological advancements we've seen. So therefore, he did his work and he did it diligently and he did it well. So where do we go from here? If you don't see an application for math topics, tell the students not to lose heart, to do their best, because it's beautiful just having those topics explained and enjoyed, just enjoy the process of doing the problems. The fact that they give you definite answers and they lead you somewhere, that method of thinking is a beautiful thing in and of itself. But at the same time, it's one of those things where you're building character and perseverance when you don't know the why, but you don't know why you're doing it at the moment, but you're building character, which will come into play later on in life. So let's land our plane. The return of the God hypothesis is here, partly because I want people to recognize the basis that faith played and the understanding people had. Like, they wanted to understand the world that God created. In the Principia, Newton talks about this, right? Though these bodies may continue by the mere laws of gravity, they could not have derived their very positions by these very laws. Thus, this system of the sun, stars, and the solar system could only proceed from the counsel and dominion of an intelligent and powerful being. That's coming from Newton's Principia, one of the greatest books in science history. So clearly, they had no issues with having faith and believing in God. So we need to make sure that we don't lie about the history of science, which is that there was a role that theology played in the lives of these people that did science. I'm not saying that people who don't believe in God can't do science. I'm saying that the fathers of the scientific revolution, a lot of those people did some of what they did with an understanding that there was a creator that had created a world that could be studied. And we see this also even with mathematicians like Leonhard Euler later on, who was a devout believer in God. He was a Christian, but he also did a great amount of mathematics. So the Bible says the heavens declare the glory of God. And that's why a lot of these guys did science. Where do we go from here? Let's help students be the best they can be in science and mathematics. But let's not be afraid to add theology into discussions in explaining to them, number one, why science makes sense. But number two, allow them to recognize that if they're looking for meaning and purpose in life, science is not going to tell them that. Science cannot, and science should not try to do that. But therefore, and if science can't do that, and we still need an explanation for why there's meaning and purpose in life, where do we turn? What do we do? And that's where theology comes in. And it shouldn't hinder your work in science. It should encourage you to give your best, because the Bible says work as unto the Lord and not unto man. So I hope to raise the next generation of scientists, mathematicians, and thinkers who also know the history and philosophy of science, theology, and logic. And so please feel free to subscribe, like, and share. I'll continue this series. We have a series going on right now where we're talking about science and the scientific revolution. We've laid the groundwork. We've had episode 1. We're going to have episode 2 and beyond coming out on this channel. This is the Living Sensibly with Amos Tarfa channel. I also have a channel called Counting to Calculus, where I show you a lot of my math work that I've done over the last 12 years. I've accumulated all the math topics that people learn. There's a book that does a great job in summarizing the ideas I have. They wrote their books independently, but this is the solutions manual for the book. It's called Counting to Calculus. I wrote the curriculum framework, where this book acts as one of the resources. So if you want excellence in mathematics, if you want to understand calculus and tie it back to how the universe works, if you want to understand Einstein's theory of general relativity, if you want to understand math and science, I would love to be a resource and a connector. I'm not saying I have all the answers, but by God's grace, I have a lot of people that have all the answers in these different branches of science, and I want to be a connector, right? So we have a STEM excellence community, which is for middle school and high school students, where we get to hang out and talk about math and science and the philosophy of science. Reach out if you want to join that community, amosthemathguy@gmail.com. Just email me and say, I'd love to join the community. Take care and have a blessed day.